Alright, functions classes, I am going to go over how to simplify fractions, but mostly rational expressions. Alright, so go ahead and get this in your notes, that a rational expression is the way that you simplify a rational expression is that first you're going to factor, and then you're going to look for those giant ones. And we learned about those giant ones last year in Algebra 2. And the reason why we're looking for those giant ones is if you look at this, every time you do this, x squared plus 2x plus 1 over x squared plus 3, and you simplify by saying that this and this is a 1, a kitten dies. And the reason why that kitten dies is I'll show you. So if we do 4 plus 2 divided by 2, so we have that plus sign, and that ends up being 6 over 3, which is 3, right? So if we had just said, oh no, this is a big 1, our answer gets simplified to 4 over 1, which is 4, and 6 plus 2 over 2 does not equal 4. This does not work. This is bad. But if we said 4 times 2 over 2, well, 4 times 2 is 8 divided by 2, and 8 divided by 2 is 4. Or, because this is multiplication, we could get that big 1. So that's why we factor. We are turning this right here into factors. So this would factor as x plus 1 over x plus 1. So that's why we would factor. Now this is multiplication. So while we're doing that, so we're looking at this example. Go ahead and hit pause. Get this in your notes. This is example number 1. Another way to say simplify, and you'll see this in your homework online, is write in lowest terms. So what we're going to do, thankfully, this is already in factored form, which means this says this term times this term, or this factor times this factor. So because it says that, I can start looking at the top and look for this factor. So I'm just going to look at the x plus 5 first and see if there's another one on the bottom. I'm not going to look on the top. I'm only going to look on the bottom. So I see an x plus 5 here, not here, not here, no. How about x plus 2? There's one here and one here. So this right here, and you'll never hear me say cancel out, but I will say this turns into a big 1. And the reason why I don't say cancel out is because now we could actually, here I'll write it down here, you can rewrite this as 1 times x plus 5 over 1 times x minus 3. And because we're mathematicians and we're lazy, we really don't need the 1 times because it doesn't disappear. It turns into a 1. We actually can say x plus 5 over x minus 3. You can leave the parentheses or not. You will see things like this. So now we're going to do the same thing. Go ahead and get this in your notes. Hit pause. Now we're going to see the same thing, but now we're going to have to do the work and we're going to have to simplify. You do need to do both the numerator, which is the top, and the denominator, which is the bottom. So when I simplify, I always start with my numerator, get that factored out, and then I'll do my denominator. So we're going to do the 5x plus 50. We always check for greatest common factor, so I'm going to go ahead and do that. I can see right away that there's a 5 in both of these, so I'm going to pull a 5 out. And 5 times x gives me 5x, and 5 times 10 gives me 50. So my numerator now is 5 times x plus 10. And I do it this way because I don't ever want to forget to write my 5 as one of my factors. Then I'm going to find my denominator, and I see an x squared minus 100. I've got two terms. X squared is one term, 100 is another term, and I have a minus sign, so I'm going to check for difference of squares. X squared is a perfect square, and 100 is a perfect square. So I'm going to factor that, and that is where we take the square root of x squared, which can be rewritten as x of 2 over 2, which can be rewritten as 1, or we could see right away that these cancel and we just get x. And then I'm going to take the square root of 100, which is just 10. So now I have my a and my b, and I'm going to set up my parentheses. So I have 1 set, 2 set, because it's a square and I need 2 sides. So I have a plus version of it and a minus, and I'm just going to put x and 10 and 10. So now it's fully factored. So now I want to write it in lowest terms. So I'm going to check to see, are there any other numbers that are by themselves in this fraction? Nope, there's not. But is there an x plus 10 on the bottom? There is. So this turns into a big 1. And so again, I could rewrite this as 1 times 5 over 1 times x minus 10, or 5 over x minus 10. Now, some of us may be tempted to continue to reduce, but we cannot. The minus sign says that we cannot break them up. So make sure you get this in your notes. Okay, so now we're going to do this one. This one's a little more complicated, and it's only more complicated because it's two different types of factoring. So go ahead and hit pause and do this in your notes, and then check your answer with. Okay, so you should have gotten at least this far with your factoring. So I have 7x squared times x minus 10 over x minus 10 times x plus 7. So now I'm going to look for the things that are exactly the same on the top and the bottom. 7, I'm going to look for a 7, and any other numbers? Nope, I don't have any. How about another x by itself on the outside? No, I don't have any. X minus 10 and x minus 10 right here. So I've got a big 1 right here. So that's going to simplify to 7x squared times 1 over x plus 7 times 1. And again, because it's times 1, I don't need to write it. Now we're going to do something a little different. Now we're going to simplify and state the domain. So when we're doing something like that, when we're doing something like that, when we're simplifying and stating the domain, the first step is to factor. Your second step is then find the domain. You have to find the domain before you then write in lowest terms. And the reason why you have to do that is if we write it in lowest terms first and then find a domain, we're going to miss something. Because if we look back over here, we got rid of this x minus 10 over here, right? This turned into a big 1. Then we wouldn't have set this not equal to 0 and solved, and we would have missed it totally. And we need to make sure that we do that. If you are in my class, you can come in and ask me why that is, and I can show you graphically. It is very interesting. I did show the classes in person. So here it is. We're going to factor. So go ahead, and I just want you to factor this and then find the domain. So go ahead and hit pause, factor, and find the domain. So now I've got it totally factored right here. So now we have to find the domain. Now remember, the domain, D, is only with the denominator. So the denominators, the D's go together. So I'm going to take x plus 3 and set it not equal to 0. And I'm going to take x plus 2 and set it not equal to 0. So then I have to subtract 3 from both sides, and I get x is not equal to negative 3. And then I subtract 2 from both sides, and I get x is not equal to negative 2. Now in your homework, and when I asked you, when I asked you for it and taught you in class, I said domain is all real numbers such that x does not equal negative 2 or negative 3. So we could do that. In your homework, when you're working on it, it's going to have you write it in set notation. So you're going to find the negative 2 and the negative 3. You put that in your answer, and then it says, hey, give it to me in set notation. What it's looking for in the box is just this part. So the way that it reads is like this. It'll say x such that x does not equal negative 2 or negative 3. Right here is the little box that you fill in. It's the second question on those. So if you get stuck on that, you can always ask me in class as well, or you can ask Miss Wadley. And I don't think that Miss Wadley's students have to do it, but I'm having my students do it. So you can just type the x that does not equal there, and then negative 2 and negative 3, just in that box. You do need to type the correct variable. So if this were a different letter, you need to make sure you have the correct letter. But again, you can always ask me for help. Okay, so this example right here, go ahead and get it down in your notes, and then I want you to do it and then check your work with mine. Okay, so you should have gotten y plus 2 over y minus 2, y plus 2 times y minus 2 over 2 times y plus 2. I went ahead and found the domain first. Now, if you hadn't found the domain, you wouldn't have gotten this right away. So if I found that big 1, which is right here, then I would have said that it was just all real numbers, because there's just a number on the bottom. And so that is why it's really important. So then I found the -2 and I got this. So good job, good luck. I will see you all on Monday. Miss Wadley will see you on Monday. I hope you have a great weekend.